Good afternoon, everyone, and welcome to this edition of the CDCA Invest Canada 2024 edition of our webinar series. This is the second to last, but we keep the best for last. Like, we have an exciting conversation coming to you today in partnership with the Alberta Enterprise Corporation. AEC has been steadfast partner. Christina Williams is the chair of Invest 2025 this year, coming to Calgary in a number of months. And as we were preparing to come and thinking about different topics, AI, you can bet, is on the topic for Invest, and you'll see it in a number of sessions on stage. And given that there's such deep knowledge in initiatives taking place in Alberta, AEC and CDCA thought, could we do a masterclass in machine learning and have the CEO of Amii come and speak to us and give us a sense of what he's doing? So that's what you're going to have today. You're going to have Alan Campbell, who's the Director of Industry Development for AEC. I'm going to pass the floor to him, and he's joined by Cam Linke, who's the CEO of the Institute. And really what I'm hoping to hear, Cam and Alan, is the practical side and what we're seeing emerge in terms of AI solutions, AI applications, how the space is growing, and how our industry, both at the macro level, but at the micro level, is thinking about capitalizing on those advancements and also putting them into the market. And for Alan and his team and all the GPs that they support, how those will build credible companies that will have fabulous exits. So Alan will be the moderator for this session. I'll remind everyone that there's a Q&A button at the bottom. You put your questions there, and him and Cam are going to take these questions in stride as they get to the conversation section of this event. And I'll come back at the end to say goodbye to everyone and to thank our presenters one last time. But thank you so much to both of you for joining us today. And Alan, I'm going to pass the floor to you. I'm going to go off camera and I'll be back in 45, 50 minutes.
Thanks so much, Kim. As Kim mentioned, I'm Alan Campbell. I'm the Director of Industry Development at Alberta Enterprise Corporation. Absolute pleasure to welcome everybody here today. For those that don't know a lot about AEC, we were founded with the mission to create a thriving venture capital ecosystem in the province of Alberta. So our mandate is to create access to venture capital for Alberta-based companies. We do this by really investing as LPs into VC funds, which in turn, of course, invest into companies. We do have several different investment strategies, so I'll just really briefly go over those so you can have a chance. And of course, if you want to learn more, you can contact me, reach out through LinkedIn, or whichever way is best for you. So we do invest in Alberta headquartered funds, of course. We also invest into funds that are headquartered outside of the province, but are passionate about Alberta and its deal flow. We do have the requirement that they have an investment professional reside in the province during their investment period. So we do have quite a few funds that fall under that strategy. We also do invest in some angel matching funds, so really trying to focus on that earlier stage gap. And when we're kicking off the ecosystem as growing, that top of funnel and creating companies is important. So that early stage funding gap is something we're mindful of. So we have that angel matching fund. And more recently, we launched a micro fund strategy, which is focused on supporting Alberta-based emerging managers as well. So to date, across these strategies, we've committed over $415 million into 40 VC funds. And then beyond investing in the funds, we also work closely with ecosystem partners. We want to ensure that the founders and companies have the resources that they need to innovate, grow, succeed on the global stage. So those innovation partners and ecosystem partners can be everything from mentorship and supports to, of course, companies and organizations like Amii, who are diving deep into AI, both the research and the application of it. So we're really excited here to introduce Cam Linke, CEO of Amii. He has a lot of similar mindsets, passionate about Alberta, passionate about the tech space and the good it can do for not only the companies and the economic value, but also just the good it can have in the world. So I'm really happy to have him here today, and I'll pass it over to you, Cam.
Awesome. Well, thank you so much, Alan. Thank you, everyone, for inviting me today and for giving me the time. Super excited about this. Really appreciative of AEC for the invite. It's been really incredible to work with AEC over the entire lifetime Amii here, and have at least a few of our recent companies that got founded from our group get funded by funds that they invested in. So we're really seeing that overall ecosystem and what the value and impact that venture and funding venture does for an ecosystem overall. So really excited about that. Excited for the conversation today. Obviously about my favorite topic, which is AI. To be honest, when looking at what generally the list of people who are going to be joining today was going to look like, I think we're in a little bit, I'm in like a little bit of a tricky spot of the level of AI knowledge. I think we maybe have some people on the call who just learned to spell AI in the last year, through to some people who probably know way more about it than I do. So I'm going to make everybody unhappy and split the difference on it a little bit. If there's a Q&A there, please use that to like throttle my presentation a little bit. Like if I'm going too fast, ask some questions to slow down. If there isn't any questions, I'm just going to keep going ahead. This is like a 2-day presentation that got distilled down into a 3-hour presentation for executives that got distilled down into about 50 minutes, 40 minutes for today. So I'm going to be flying through. So please stop or like pause me as pause for questions as I'm going through. I am going to do my best to leave time for questions at the end. It's just such a big topic right now that I want to make sure I'm hitting the things that people are thinking about. With that, just to start, I mean, we're based here in Edmonton, Alberta. We're based on Treaty 6 territory, which is traditionally a place of gathering and of sharing. And we're excited to continue that history here of gathering and sharing ideas, especially around AI. I'm Cam. I'm the CEO at Amii. Most of my background has been on the product investing and startup side of the world. Amor and her team are actually the ones who did the hard work on putting together this presentation. So everything that's right in it is because they did a great job, and everything that's wrong is because I screwed up what they set me up for success on. And then, just overall, so what we're looking at today. So one, really high level, trying to get everybody an understanding of AI, machine learning, what those things are, and areas that we're seeing impact and ways we're seeing businesses leverage it. And then, into some very specific topics around generative AI, what goes into AI development, and then just some things around, this is such a fast moving field. How do we do this all responsibly at the end? All right. I'll skip through that part. Just like if you have an Amazon Prime subscription and you get like a 1-minute ad in front of all your movies now, you also get essentially a 1-minute commercial from me, which is just a little overview of AI in Canada and Amii. So we're one of Canada's 3 national AI institutes. Canada has been a long investor, and the province of Alberta have been long investors in artificial intelligence. Our institute's been around since 2002, and we're able to bring some of the top minds in the world to Alberta and to Canada by investing in world-leading research and training. As I mentioned, Canada was the first country to have a national AI strategy, has invested over $500 million to date, alongside our colleague institutes at Mila and Vector and our collaborating institutes, the Canadian Institute for Advanced Research. So really excited. We all have this kind of same basic premise that in order to drive forward AI leadership, there's these 2 core pieces that we need to do, which is advance leading edge research and training, leverage that knowledge, talent, and technology to drive out industry adoption. And this cycle, and making this cycle as quick as possible, is really how we're going to build an incredible economy, incredible AI economy here. At Amii, we really work and think about companies, not about size necessarily, but just where they're at or where a department within their company is at as far as AI adoption. And that's everything from exploring, hey, we're just looking into the area, through to completely advancing. And it's not about, for us, the way we think about it isn't like anything's right or wrong. It's just right sizing and doing what you can to move from the spot that you're at forward, and progressing from there. We've worked with a bunch of companies. We're over 500 active researchers in our group. We're nearly 50 CFAR chairs and fellows within our group. And these numbers are a little bit old, To date, we've now worked with almost 500 companies on the industry side. So really marrying the two things of research and talent, or research and industry. And the last two things, so this is Dr. Richard Sutton, who's our Chief Scientific Advisor, a fellow here at Amii, and runs the Reinforcement Learning and Artificial Intelligence Lab at the University of Alberta. He's a great example of the type of researcher that we have here at Amii, which is someone who's thinking incredibly deeply about the field, advancing the field. For those who have recently seen things like DeepSeek, which I will talk a little bit later, which was called that was their Sputnik moment for AI. Well, Rich has actually created two Sputnik moments for AI. So one was that, which was very based on reinforcement learning. And the other one was actually China's Sputnik moment back in 2018, 17, when Lee Sedol, when the top Go player in the world, was beat by a computer for the first time. And that work came out of Rich's lab at the University of Alberta. And this overall AI story is something that we should be incredibly proud of as Canadians, and I think is an incredible arbitrage opportunity for investment in Canada, because the core technologies underlying AI and underlying the most recent advances are all coming out of Canada. So ChatGPT is probably the thing that most people know about when they talk about AI right now. It's built on three core Canadian technologies, which was attention by Yoshua Bengio in 2014, transformers by Aiden out of Toronto in 2017, and reinforcement learning, specifically policy gradients, which have been pioneered in Alberta by Rich and our group overall since 2002. So we're driving forward the field overall. And I really think there's this incredible opportunity to invest further in the opportunities that are here in Canada. It's a bunch of things here. You can see the slides later if you want to see some of the fancy numbers and fun things that we've been able to do. And this is an example from 2023. The last part I'll just say as an advertisement, would love to work with any companies. If any of your companies are interested in AI and driving forward what they do, we would love to talk to them. And then we run a conference in May 20th to 23rd, that brings together pretty much the entire AI world, from researchers to startups and investors and large companies and government, all together in one conference. And we would love to see you there and have you there. All right, commercial over. What is AI? What is machine learning? We're going to start really high level. I probably already made the mistake of using the two interchangeably here already. So just really quickly, we talk a lot about artificial intelligence, we talk about machine learning, and you probably also heard a lot about some things like deep learning, as people have talked about the field. So artificial intelligence overall is this entire field of getting machines, getting computers to be able to act in an intelligent manner. And that sounds really generic and broad, and it is. And over time, if you look at historically, a lot of this was computer vision, natural language processing, robotics, and a lot of these were systems where there was a lot of human heuristics built in. So if I wanted to build a cat versus dog classifier, I would have to build in a lot of individual heuristics about the difference between cats and dogs, so the algorithm could take those into account to be able to build a successful classifier. And so some interesting results have come out of the overall field of AI, but a lot of things kind of capped out. The ability to detect things well in images. At some point, there was just too many heuristics and too much having to add another rule or another kind of module in order to try and make something better, that made these systems not be able to generalize that well. And so machine learning, and one of the reasons you hear machine learning and artificial intelligence used interchangeably, is because machine learning's really become the bulk of the field of artificial intelligence overall. And the reason for that is the change in how we build these systems. So instead of my dog and cat classifier having to have more heuristics built in, suddenly I'm able to, in a machine learning system, have the system be able to learn from more data. So the system improves itself, not by more lines of code being written, but by more data being ingested and it being able to learn from that data and improve itself over time. So suddenly, instead of saying like cats and dogs, I need to do a different whisker classifier, now I can just feed it more images of cats, more images of dogs, and the system learns to represent the two and learns to make a distinction between the two. And so that's the reason, in 2012-ish, there was a big advance coming out of Jeff Hinton's lab on ImageNet, where suddenly these systems were significantly better at the ImageNet competition. And that was one of the big things that really kicked off a lot of the recent wave of machine learning, or a lot of the wave over the last decade and a half. Two of the things, just as far as technology trends that are reasons that this has happened, are one, the rise of GPUs, and then the second is the rise or the fall of cost in data storage. So we have Moore's law going in one direction up, which is the doubling of compute every about a year and a half. For $1,000 of compute, that continues to double, even with new kind of technology changes. And then the decrease in the cost to be able to store data. And so these systems, these machine learning systems that are really good at ingesting a lot of data and learning from large amounts of data, suddenly have hit a tipping point of a large amount of data available to do interesting things and the compute necessary to be able to run the calculations to be able to do that. And this is one of the kind of extra wins of deep learning that we've seen. So deep learning is a machine learning method. It's one of many machine learning methods. And the interesting thing about deep learning that it really brought to machine learning is, as there were still heuristics in a lot of cases around how something would be represented. So I'd have to write representations or have kind of different modules around how an image might be represented, and then fit into kind of a machine learning classifier. Deep learning is really great at learning representations right from the start. So it can just be fed raw pixels, be able to learn from those raw pixels to be able to improve its predictions over time. So this is the really big advance. And as we get into text, as we get into different modes of data coming in, this principle of being able to learn large amounts of data, learn the representations of them, and then do really interesting things on top of that representation, is really why we've seen this huge advance in the last number of years here. Okay, so quick summary of that. You're now maybe, at least language-wise, above 3/4 of the populace. And for each of those, the big part, overall, looking at this kind of investment-wise, is to say, at what area of each of kind of that development piece, does our company potentially have a competitive advantage? So do we have a competitive advantage in the data coming in because we can train something better, and more data means that we can train better? So do we have a proprietary set of data? Are we generating unique data? Are we generating cleaner data? Something like that. Is there an advantage there? Is there an advantage in the architecture of what we're doing? And the hint is you probably don't have an advantage there. But is there's in some cases, for instance, in drug discovery, we've seen people do interesting things, keep what they're doing secret because they found a little bit different way to be able to model the representation at that point. And then at the kind of end of it, in the learning piece, as the system's learning from feedback, do we have a unique or proprietary source of feedback that's improving our system? So maybe a better access to labelers of medical images, your Google, and maybe you're just getting better feedback from the large amount of people using your system. So at the back end of that, is that giving us better label data that we're able to then feed into the system and continue to drive this loop and this process overall? All right, no questions in the chat. I've either like bored everybody already, or I'm moderately keeping up. Okay. So the other kind of part on this, so moving into just how we're seeing AI be used, and one of the things whenever we talk to startups, investors, companies, is to take a step back a little bit from the technology itself, and get into how we're seeing it actually drive value and give a bit of a framework for how it's going to drive value in an organization. So it's less about thinking about like, are we using deep neural networks, or are we using transformers, or whatever the technology of the day is, and more, what is the actual valuable business outcome that we're trying to drive, and where can machine learning drive value for that? And the way we work with companies on thinking this through is really saying there's 5 core ways that we see companies drive business value using machine learning. And that's project, produce, prevent, promote, and personalize. I'll run through each of those. One just quick note before I do, you've seen companies go down this path of trying to use this framework, and there's kind of 2 ways of thinking about. One is to look at our organization overall and just say, like, is there anything in our org that this can be used to help? And it's good to look at that lens just to see, both as an opportunity, but also as a threat. Like, where could somebody else be doing the same thing that our organization is doing, only leveraging this, and maybe ending up with a competitive advantage. So it's worth looking at it through this lens, but it's also, where we've seen kind of more immediate impact is where companies have said, okay, here's our strategic pillars for the year. Here's the 3 strategic things that we have to drive this year. So maybe our focus is entirely on operational efficiency, or our focus is entirely on customer experience, whatever. Looking within that pillar, how can each of these be used? So instead of saying, hey, we need to look just at like how we can better personalize across the whole organization, is there something within our operational efficiency piece that personalization can improve what we're trying to drive there? And so instead of trying to do this writ large, doing it within each of your strategic pillars really helps teams have the focus and the intention about what they're doing to drive this forward. So just to get into each of these really quickly. So project, this is one that most companies are kind of used to, in that they might probably been doing this using some sort of statistical method already. Projecting out the price of data of something. This is a company called Honest Store here in Edmonton that shares real estate data and makes daily price estimates for each property using a proprietary valuation model. So projecting forward, projecting how much inventory you need, so you're not over carrying or under carrying inventory. What machine learning we've seen is a lot of the statistical methods are allowing for better things here. I'm going to get to the questions once I rip through this really quickly. So produce is the next one. This is a company out of Regina called Dot that got acquired by, I think, Raven. So we worked with Dot. They're basically an add-on to farm equipment to be able to create an autonomous farming platform that both allowed companies to reduce potentially the number of workers needed on a field, but even more importantly, to actually optimize the field itself and optimize the farming of that field to produce more output. Prevention is, again, a pretty obvious one. We have a lot of companies who come to us asking around like predictive maintenance. How do I prevent failure? Here's an example of a company. We didn't work with this one, but they're out of Regina that does prediction around disease in crops to be able to identify that and isolate quicker to be able to reduce the amount of crop loss. So this piece around prevent's another big one that, projecting out into the future, matters a lot, and being able to project when you may have an issue is a big opportunity for companies. We worked with one company on projecting or preventing emissions, and their cases around the detection and optimization of their equipment to be able to prevent emissions. And one of the interesting things that we found is that produce and prevent can end up working really well in tandem. So you can end up having, for instance, a pipeline that you probably need to keep a significant margin of error to prevent any issues. If you have more confidence about what that margin of error is to be able to prevent failure, you can actually run your system hotter. So you can run, for instance, more through a pipeline and end up producing more simply because you have better models around how you can prevent challenges down the road. And then the last two we're seeing kind of more recently around promote. So this is, again, typically what people have been doing in the past around audience segmentation, but the ability to promote to the right people at the right time, use new methods around graphs to find the right communities to promote to new technologies around localization to get the right message to the right person is really important. And then the last one, and maybe the one that I'm most excited about recently, especially unsurprisingly with generative AI, is this piece around personalization. And so this is an ed tech company that works on personalizing lesson plans for students. And when you look at the bell curve of students in a classroom, you have students who are really far ahead, you have students who are behind, you have students in the middle, and one teacher trying to do that for everyone. And the ability to personalize the right thing that matters to that student in the right way to help them either they're already ahead, keep them engaged, they're behind, help them get up to speed quickly on the things they're behind on, is an incredible opportunity. And we're seeing this writ large, where instead of the same message, for instance, going to the engineering team, the marketing team, the investment team, different messages, the right message and the right tailoring of data coming out to the right people at the right time within organizations. Obviously, marketing messages out. One of our alumni founded a company called Forethought AI. That's a customer service company. With one of their large telecom customers, they were able to bounce about 40% of the inbound customer service requests. Instead of those having to go to a person, were able to be dealt with at the same level. And so suddenly their call team was able to really engage on their high value, bigger challenge problems that were coming through. So this personalization piece is really big. Just quickly before I kind of go to a couple of the questions there, when should you not use AI? A couple pieces on it. Just in a lot of cases, the challenges that we've seen are either one, somebody can just use a simple method. The second one is they don't have a clear business case. Like what is ground truth? How am I evaluating this? What is the clear business outcome that isn't a fun technology outcome that this is going to drive forward? And then the kind of human management of how is this going to be integrated into our company and our system overall are really big areas that companies need to think through about when or when not to use AI. Okay, I'm gonna pause and take a quick look at a couple of questions using. Okay, so the question is, we own multiple companies, our team and leaders are using various tools, Grok, Gemini, Copilot, etc., getting quite efficient at getting good leverage on those. The big block is how we integrate into our workflows. Our teams are not that technical. Yeah, great question. So this is one overall that we just see as a massive challenge in Canada overall. This piece around AI literacy. And so one is getting the teams literate. And then the second part is, as we get through that first little hurdle of literacy, that second part that's closer to like an AI ops and AI integration piece, where it isn't just about understanding ChatGPT or something like that. How do we get our IT, our engineering teams, who are often the ones tasked with deploying this, up to speed in an efficient manner to be able to deploy these things across our workflows? I'm not sure if I have a great answer for that. I think it's more a great point that Brendan's bringing up there. Our biggest thing and that we found is a significant number of the blocks go away the more literate your team gets in AI overall. And the nice part is there's a huge there's a huge amount of training out there now to really targeted at each of your team members that are taking that on. Christina, hi Christina. What do you see coming next? Should investors be careful of? Are there areas that will be difficult to be competitive in because the large players are so far ahead? Great question. I'm going to actually slightly pin this one to a part once I get into generative AI a little bit kind of down the road. The one part that we are seeing overall is that it's really expensive to build new models, and every day somebody's releasing a new model that seems to beat the one before. So this is a tough race to be in, and unless you have some sort of corner on talent, like Cohere was founded by one of the people who originally came up with the transformer architecture. So unless you have a corner on talent, a corner on data, a little bit like Grok does with Twitter or Google does with YouTube and search, you're gonna have a really hard time competing in that arena. And so on that side, on the foundation model, kind of large scale model side of the world, I'd really be looking at, is there any sort of, like, do you have any sort of data or person competitive advantage? And if you don't, then you're going to be in a lot of trouble. And the part that we've seen recently, again, I'll talk about DeepSeek in a couple minutes here, is that even little architectural advantages are suddenly bringing in other groups, and that advantage that you thought you have, you suddenly don't anymore. And so, you know, the fortunate part is these things actually go back in many cases to like foundational business principles. Where's our moat? Where do we have data or people advantages or customer advantages that others don't have? And then how can we build on top of those? The parts where companies end up more likely to get killed is that they're not willing to make the changes internally to be able to you know, in some cases kind of cannibalize their own market a little bit to get to a better place. And so the competitors or a young upstart ends up cannibalizing their market for them. So I'll answer, hopefully I'll cover a little bit more of this later. Christine, if there's other things that I'm missing in there, please I'll chime in there. And then last thing before I move on, Hannah, highly recommended efficiency AI tools for email management, note-taking. So I will say I would use one of the like Gemini, Cohere, like one of these internally that is already in your email inbox. Gemini, I find, works really well. We're on the Google platform. I've heard great things again about Cohere. You know, Canadian company will do a deployment behind your, you know, in your internal system if that's what you need. So I haven't found anything of any of the kind of individual ones other than the kind of big players in that space. Another tool that I adore, this is the one that I think is the best designed AI product right now, is Notebook LM. If you haven't tried this, it's from Google. If you're looking at doing a deep dive into an industry, if you have papers like, hey, oh, we just had this company who's doing this, they published these 2 scientific papers, you can put it in there, it'll create a summary for you, it'll create an FAQ about the paper, it'll create a 10-minute podcast about it. You can ask the podcast people to be able to argue about what's right or wrong with the paper. It is the best designed tool right now, in my opinion, that's sitting on top of an AI product. So I highly recommend checking out Notebook LM. Okay, I think I'm way behind, so I'm going to keep flying through here, and then I'll try and answer more questions again in a bit. One of the other big things that companies hit as a challenge is this piece around a life cycle. Around machine learning operates different than a typical IT or engineering deployment. And this is often where companies get tripped up, is they're used to, I go to my board, I say, we need an app, here's the budget for it, here's the team I need, it's gonna take a year, I spend $1 million, I build an app, it gets deployed, and I get fired whether it like works or not. Or I maybe do or don't get fired based on whether it works or not. So this is like a typical thing. Boards are used to being able to govern around this. Management's used to governing around this system that's like this clear kind of waterfall method of something worked or it didn't. An IT deployment worked or it didn't. Machine learning is very much this life cycle that's way more like product development than project management. It's way more like science and engineering, in that you have this process of moving backwards and forwards as you learn more in a life cycle, in the life cycle of it. And so I'm going to go through this like really quickly, and I'll give you a quick example of how it happened with a company. So, you know, it starts with business understanding. Do you understand the problem, the value that you're trying to solve? Moving on, then, do you have the data that you need to actually be successful? Once you move beyond that, and I'll give you an example. We worked with a company, or wanted to work with a company that was priced hotels, and they were, you know, I guess I'll just leave it at that to obscure who it might be. And they were like, look, we've been doing this forever. Dougie's been pricing these hotels in the corner for the last 20 years, and he's pretty good, but we think we can do a better job using machine learning. We're like, yeah, probably can help you there. What kind of data do you have? And they're like, oh, well, we haven't recorded any of the data. And we're like, well, you're going to need to be really nice to Dougie for another 20 years as you collect that data. So even though they have a great business problem, likely can have impact there, they didn't have the data to be able to be successful in it. Once you actually feel like you have a good understanding of the data is when you get into the parts that we find more fun around machine learning modeling and evaluation. And then things don't stop there. You actually have to deploy this out in the world and validate that things are continuing to operate as you continue to operate as you have them deployed. So, sorry, I just want to make sure I'm still on. I see a loading screen. Okay, so you have this entire life cycle. What does that actually look like in practice? So we worked with one organization, and I'm going to again kind of try to obscure a little bit about what they did. So we'll call them a tire company that was projecting out the amount of tire inventory that they wanted to carry. So this started around, yep, inventory management makes sense. We're going to continue to do that. Moves into, do we have the data that we need to be able to do this successfully? In their case, they thought, you know, what would be great is the number of cars purchased as a data set to be able to make this prediction. We're able to acquire that data set, moved into the modeling phase, and their model was terrible. And so they had to go from, you know, okay, this is great. We think we have the right thing, to actually backing up to see if they could even understand the problem in a different way and see what other data they could get their hands on. In their case, they ended up, you know, doing some data analysis and being able to look at maybe fuel sales was actually a better indicator of tire wear and tear and a better predictor. We're able to get that data, moved into modeling. And it did a great job, incredible predictor for them. This worked really well. And then they deployed it and across their stores. This is great, things are going well. And then here's one of the big challenges that come up in machine learning. These crazy electric cars come along, and now their fuel algorithm suddenly doesn't work that well for them anymore. And so this thing of like, hey, the system can be deployed, but the world changes is really meaningful. And then all of a sudden this kind of backs up and is something that you have to kind of start again and see if you might need to do more modeling or really understand data in a different way to move forward. So I'm going to fast forward through this section overall. I gave you the overall piece there. But one of the big parts overall is, as a company, you don't want people like me just charging in with their neural networks thinking they're going to save the day, but you actually need to be able to bring domain expertise and insight into what you're doing overall at each of these steps. Okay, so just to try and play catch up, the last piece kind of on this is that all of these things are great. You can have all these incredible pieces, end up with a great model. But the other big challenge is, do you actually have the engineering team to be able to deploy this properly? An example is Netflix. They ran a prize that a team from our group actually ended up really high in at one point around doing better recommendations. And they never ended up deploying the result because the cost to deploy and maintain the model weren't beneficial compared to the predictive power. Now, I know they're using more and more, you know, machine learning and recommendations as the companies continued to grow, but at the time, it was something where the engineering costs of being able to deploy this and the change management of what it meant to deploy it ended up not being valuable enough. So it's kind of this last piece around this of, this is great, we can get to a point that we have a great model, but that things don't stop there. And it's often the like people and process parts that end up being the challenge in actually deploying machine learning systems. Okay, I'm going to take a couple questions quick, and then I'll go through close to the last section and then have some questions at the end. Do you have any I answered that one already. Can you share a high level once you use ChatGPT versus Perplexity versus Grok? So what we have done is internally is we've just tried a lot of them. So you can go online, you can see benchmarks and just see how each are performing. And I would probably just start with saying, like, if it's a software engineering thing I'm trying to solve, who's the highest on that benchmark right now? And I would just start there as a good heuristic for where to start. Who's on like a sensitive data set, who's better, higher, or lower at hallucinating. If hallucinating is a big challenge, start with a group that, or the algorithm or product that's best at dealing with hallucinations. So I would just start there as a heuristic to get going. And then from there, what we've done is we've just really set this process of trying and then sharing internally. So we'll have like one of our group will have like our standard tools, but someone will be like, hey, we're going to try this in Grok. Hey, we need more direct citations of where this information is coming from. I'm going to try this in Perplexity. And we just, as an internal thing, then shared, hey, this is something that's worked. This is something that hasn't, I'm seeing, you know, whatever, this tool is better on the code generation side, these types of things. So for us, the high level heuristic is looking at the benchmarks just to see your area. And then the like people part is really a sharing part, people being able to try and experiment internally. Okay, so generative AI, this is like probably the biggest reason everybody's interested in AI right now. Accenture a year ago predicted that there would be a big uptick in companies that embrace generative AI over the next 12 to 24 months. I guess they were pretty right. Something that we've seen just absolutely take off. And so when you look, when people say generative AI or Gen AI, it's really AI that generates new content, images, text, code, video, these types of things. And it ended up being, so, you know, these things that felt very human, like me writing, you know, saying, hey, I want an image of a beautiful sunset with a cow standing on a beach in the Milky Way galaxy made of Cheerios in the sky. Okay, this is great. This is a very human thing that I'd have to do in Photoshop, or somebody would have to do for me because I'm terrible at Photoshop. And suddenly in a generative model, I could have that, which, to be honest, is pretty great, pretty close to what was requested there. And so this piece around these things that were these kind of very generative human tasks that seemed like they were generating very human outputs really was kind of the revolution of the last couple of years here, and really changed this piece, as somebody I heard kind of mention today, of the democratization of intelligence. So a lot of these things that felt like you needed a very specialized skill, or, you know, there might be a little bit of a landlock on intelligence or insight. Suddenly there's a much more kind of a bigger democratization of that overall. And language models are the big one that you know, people I think interact with the most on a day-to-day basis. They're deep learning models that are trained on massive amounts of data for language-based tasks. Again, their machine learning is a piece and the core driver of what is the creation of generative AI, and language models and transformers are, again, a method used to train machine learning. But these things are really, really expensive to be able to train. The estimation of ChatGPT was you know, close to $100 million worth of compute to train. That Gemini Ultra from Google was close to 200 million. There have been estimates that in the near future, some of these things are going to cost $1 billion worth of compute to train. So this is something where like these models are getting bigger and bigger and bigger. And what we're still finding is that the bigger they are, the more capacity or the more capability that they end up having. We are seeing a little bit of a tailing effect on that, which is why at least some people are estimating why ChatGPT-5 or GPT-5 hasn't come out yet. But it's still, with Grok 3 coming out and then being trained on the largest kind of cluster out there to date, it seems like these scaling laws continue to hold. So overall, just to give you an idea of how these things work and why they've been successful, they're very good at predicting the next word. And this is basically the whole history of this kind of language modeling piece. Is I would have a sentence and I just keep kind of predicting the next word. So I might start with the Edmonton Oilers and it'll predict and say will, win, and it's just a probability of what the next most likely word will be. we thought maybe that was going to happen in 24, you know, maybe 25. The big part on these is historically, as these things happened, they tended to end up becoming gibberish over time, because something like, I'd say this in the middle of a sentence, and the system didn't have a very good way of understanding what this referred to. And so connecting sentences and connecting paragraphs became very difficult across these systems. And what attention and transformers really allowed the systems to do is to be able to connect those words back and forward in time into what that word was referring to. So now this, I could know that I was connecting back to this specific word or this specific topic back in time. And so this allowed these systems to go from descending into gibberish to being able to create these sentences and paragraphs that were suddenly really, really coherent. At the same time, the thing they're great at is being coherent. They're not always great at being correct. And so this is where this idea of hallucination comes in around, you know, the system starting to generate data that doesn't make sense, or generate sentences that don't make sense as they continue to go. Okay, and so, and maybe diving in a little bit to what Christina was asking about earlier, like what's on the horizon and what are some like big kind of questions and maybe some things coming up. So one big one is reasoning. If you've seen some of the new models like O1 out of ChatGPT, that will take longer as a response, or some of the deep research models coming out of pretty much everybody now. It's worth checking these out. It's worth trying these. It's unlocking new use cases. But typically what this is doing is making the system spend more time thinking internally about something before it just generates an answer. So instead of just starting to generate text, it will internally start to say, okay, here's 3 answers that could be the right answer. Which of these is predicted to be the most likely? Okay, that's the next piece I'm going to use. Now, given that, which is the next thing? So it's almost talking to itself internally and doing like internal prompting as if you were going back and forth to try and reason to get it to a good spot. It's doing that internally itself. And for those who, again, like to continue the Yay Canada piece, a lot of this is built on this idea called chain of thought. And that chain of thought piece was actually something that came from one of our researchers, Dale Sherman's, in our group here. So again, we continue to push forward the frontiers of the field. So this piece, you can see the diagram on the left of this piece of thinking through you know, what this looks like. And you can see on the right, you can often unclapse the text and see what the conversation essentially was having with itself. The other big thing that's really on the horizon, and again, has really brought a lot of attention to folks, is this piece around DeepSeek. So one of the things that DeepSeek did was be able to train, again, there's some argument about whether the dollar amounts they're saying they used are right, but still they were able to train a model that was state-of-the-art or close to state-of-the-art for a significant amount less compute than before. So suddenly, you know, this is one of the reasons NVIDIA stock dropped, you know, a large amount one day, is suddenly it was like, well, wait a minute, maybe we don't need the amount of compute to be able to train these really large models. And the big advance for them is they really, really integrated reinforcement learning into the process overall. So this piece around that chain of thought and then going back and having this as a loop in training, they used reinforcement learning to really improve that loop internally, and make better use of the training data that they had, so they didn't end up having to run as many cycles to be able to train their model overall. So this is a really big piece. Again, you've seen the field is a very like catch up quickly field where everybody then start to integrate this into what they're doing. And you know, this, you know, NVIDIA's stock ended up going back up. Don't worry for those who own it. We still need GPUs. But this piece of suddenly the idea that like, hey, maybe we might be able to train these models to be smaller, to end up on our phones, to end up having something that is as good as a large model, but on a doctor's laptop, so it maybe can be air gap. These types of things all of a sudden went like, oh, this is closer than we thought, or maybe this is being unlocked in a way that we thought couldn't be done before. So this piece around DeepSeek and really integrating reinforcement learning into that loop has been really big. And then agentic AI. So this is a term that folks have probably heard about. The AI agents are going to be the big thing in 25 or 26. And this is basically like an expansion of this reasoning piece where you end up having these submodules able to go out and make decisions or take action and then bring those actions back. So I can do something like, say, put together this report, and I can have an agent go out and evaluate this data on this site. I can have this one go and evaluate some internal data that we have, all these types of things, and can bring those activities back into the model overall. And so the big kind of thing to look at and keep in mind here is as we talk about business processes and integrating business processes into what we're doing, the ability to have these agents take on a number of these business processes and integrate them together is something we're seeing as becoming more and more effective. I wouldn't say this is a perfect world. This is an emerging area, but it's something that's improving continually as more research is being put into it. And I will say, as a quick kind of plug back to reinforcement learning, and maybe one message just overall about generative AI, which is it is one area of AI. It's maybe the most exciting in that it's the most like personal and visceral, but we're seeing machine learning have AI have incredible impact in many non-generative AI areas, predicting whether or not a piece of equipment is going to fail. Or here an example, using reinforcement learning to be able to have robotic systems, as an example, learn over time from interacting with the world. And we're really excited about this company, started by one of our Amii fellows, Martha White and Adam White, called RL Core, which is using AI, using reinforcement learning to be able to optimize water treatment, which is both exciting because it allows it to use less chemicals and less energy in a deployed system. But also, if you know anything about water treatment, one of the reasons we still have boil water advisories is less to do with equipment and more to do with people operating that equipment and whether or not we have the trained people to be able to do that. And so the ability to keep these systems running optimally in between opportunities for an operator to check on the system is an can be an incredibly high impact thing for these systems. So this is something RL Core and places we're seeing AI that's not generative AI take place. Okay, so last piece, and then I'll finish off with questions to run through there. So just responsible AI, it's something that, to me, the biggest challenge we see are companies ending up, it's like sins of omission, not commission. Like people are not trying to do something bad with AI. There's very few Mr. Burns evil people out there trying to do something really bad. It's more somebody not thinking about the fact that, hey, I'm trying to do better with a sentencing prediction algorithm, and I don't think about the historic bias that's in the data set that I'm using coming in there. So just a couple things are, one, thinking about privacy and security as your data is going into these large systems and your company's information is going into these large systems, and these systems start to train depending on what the privacy and security agreement is, your data may be trained into a large language model, and your company's proprietary data may be trained into someone else's model. So a big thing to think about there. Right now, there aren't a lot of regulations and standards. These are kind of new and emerging. What I recommend to everybody is go back and check with your kind of standards body, whether it's the legal profession, engineers. Everybody kind of has a recommended standards for their group right now, and start there as some internal policy to look at. And then the last thing is thinking about areas where, as you're deploying these systems, it may be worth trading off predictive power for explainability. And when you look at, for instance, in a hospital setting, just saying like, oh, well, that person just got this liver cause isn't a great way of making decisions, or might not be an acceptable way of making decisions. What went into that decision, why and when is really important, and how that prediction came to be. Okay, so I'm gonna end there just to make sure I have some time at the end. We do have a masterclass for investors. If you would like to check it out, the QR code's on the screen there. I'll leave it up for a minute. Other than that, I'll go back to it. But other than that, we would love to talk to anybody who's interested and would love to help however we can. My very, very last thing I'll say is, I was just recently at the Paris AI Action Summit. Every country in the world's thinking about how to hit the gas pedal on this as much as possible. As Canada, we tend to often wait and see what everybody else is doing and then either be a fast follower, often more likely a slow follower. This isn't an option in this field. This is the defining technology of our time, and we need to do everything to lead as Canada. I believe that investors have an incredible role to play in that. I'm a big believer in venture, and let's figure out together how we can lead here in Canada, how we can create the best deals and the biggest exits in Canada overall, and we would love to be part of that at Amii. Thank you so much. Happy to answer questions. All right. Maybe all of you disappeared 20 minutes ago. I've been talking to myself. So just a couple things. Paul asks, what benchmark should we pay attention to? There is, so there's an LLM benchmark. If you just Google LLM benchmarks, there's one that just shows what all the recent ones are. I can get a more from our team to follow up on what that one is, because I haven't had enough of my coffee over here yet to answer that. And it's not sticking in my brain. The second one from Paul is, the brain uses about 20 watts of energy, which is way smaller than any LLM. Is it possible to replicate the form and performance of the human brain? I think this is a fantastic question, and something overall we need to be thinking about. And I'll just say that the field itself, like, AI is not solved in any way. Just bigger models are only going to get us to a certain point, and we have different researchers and different people who are looking at from the different angles. I'd say, like, Rich is somebody that I always find really interesting. Obviously, I was a student and we love Rich. He's here, so we're extra interested in him. But like, his way of thinking about systems learning and agents learning in this continual online loop is going to be an area going forward that should be leveraged more than it currently is. So I think there's a lot of really interesting questions in this area, because our language models are using kind of billions of dollars of energy to try and replicate what my little mushy brain does for a couple cups of coffee and some eggs in the morning. So there's a lot that we can do there. Kim, I see you on there. if I missed the question, please feel free to reach out to myself or the team. Kim, I don't know if there's any questions, or you're just trying to boot me off the screen.
No, I just wanted to
thank you
make
everyone
sure
for having me.
you were coming to an end. This was wonderful. And if there, I see that you answered Paul's last two questions. Those are the last two that I saw, and I answered one live for the recording. And for anyone who registered for this thing today, you will receive a recording in your inbox, and it's also available, and it can be circulated to anyone who you think may have missed this and thought it would have been awesome to listen to. Cam, I just want to say thank you to you and AEC, Alan, and the team for taking the time to do this. I know we're going to spend time with Amii again when we're back in Calgary in May. Right after your event, we come, and 700 of our investors from Canada and across the globe are going to be coming together to spend a few days talking about the potential of the asset class and putting a spotlight on what's happening in Calgary, which keeps growing year over year, quarter over quarter, like the momentum that Christina and her team and the companies that they support are doing. And what you've just laid out for us is really a sense of the potential, what's there today and what's to come. And I love and share your enthusiasm that we should not be waiting for the world to take the lead, but this should not be a heritage moment. We should be capitalizing on it, shouldn't we? So with that, I will thank everyone who joined today. We'll be back with Faskins as our last sessions, I think next week or the week after. And to all of you who have not registered, and if you're a member, there's just a few days left for early bird, and then it will be regular pricing. Registrations are open, and we look forward to seeing you. And Cam, I look forward to meeting you in person.
Awesome. Thanks so much for having me today. Have an awesome day, everyone.
Thank you. Thank you, everyone.